Had one before or seen one. Today we're going to do scatterplots. Tomorrow we'll do line of best fit. Okay. But scatterplots is a way to show numerical data Okay, Hassan, your music is so loud. Using two variables, so x and y. All right, we're going to first talk about a scatter plot that's already done. So you can go ahead and glue this in. I'd glue it in towards the center near the top here. All right, so go ahead and get this glued in the center, in the top. We're just going to talk about the different parts of a scatter plot. Should be, again, a little bit more like review today, and or if people talk and tell me some answers, that would be helpful. It's not making this so boring. Alright, so get that glued in. And then as we glue that in, we are going to do a couple colors on here. So if you want to grab out 4 colored pencils, you can. If you don't, that's okay. It's just to highlight the important parts for our brain to look at. Oh. There we go. All right, as you take a look at the scatter plot, what are some things that are important about the scatter plot? What do you see? What's some things that all scatter plots should have? Good, they have dots. Our dots are the data. Good. So data points. And data points look like X and then Y. Okay, what else do we see? What else should all scatter plots have? An X, good. What's an X? What's our X here? Temperature, good. So this is our x-axis. So the actual line itself is the x-axis. The temperature is what we call a label. And it does have what we're measuring in. We're measuring in degrees Fahrenheit. Okay, what else do we have in this graph? What else do you see? The y's, good. We have an x-axis, which means we probably have a y-axis. And what is our y-axis representing here? The water that we are consuming. Consuming means to like drink. I should have colored this blue also, sorry. Okay, and we're measuring it in OZ. What does OZ stand for? Ounces, good. So this is our y-axis. And again, this is just a label. Could also be called a title, I suppose. I like to call them labels. Okay, and what else does this graph have? An overall average water students drink. What would we call this part of the graph? A title. So we're looking at average water that students drink. We have temperature and the water consumed. One thing that I would request that whoever did this graph, they would fix is that this temperature, do you think that this is the temperature of the water or the temperature outside? Yeah, I would maybe think outside, but maybe it's the temperature, maybe people are drinking really hot water. I mean, it's not really hot, it's warm. Warm water? I don't know, it's kind of gross. And as water gets warmer, would more people drink it? Probably not. So it's probably temperature outside. The hotter it gets outside, the more students drink. It's going in an upwards trend. Okay, there's one more thing on here that we want to call attention to, and that's on this bottom part on this x-axis here. It's this kind of looking M kind of thing. It's supposed to be more of a lightning bolt than an M, but that's the way it looks. Okay, we're going to write that definition because that's something important. Yadiel, get off your phone. Kian, get off your phone. Omar, off your phone. Hassan, Rowan was supposed to talk to you. Yell at you. Alright, this is a break. So as we take a look at the x-axis here, what is the x-axis counting by? What does it look like it's counting by? 5s, and then it goes every half, so like 2.5. But it doesn't count from 0 to 80. From 0 here, it jumps to 80. If I had counted by 5s all the way from 0, there'd be a whole lot of my graph that would be blank. There won't be any data there. So this break allows us to jump, okay, and then spread out the data. If we had to go all the way from 0, we probably would have had to count by 10s or 20s, and then all this data would have been squished, and then a lot of the graph would have been blank. So it's kind of a waste of graph space. So we use a break when we jump from 0 to the first number. Okay, we use it when we jump from 0 to the first number. So if we can jump from like 0 to 1,000 and then count by 10s, that'll make it look better on our graph. Sebastian? Bruh. All right, we have 2 other big things that we're going to do today. We're going to talk about correlations, and then we're going to create a scatter plot, which most of you will probably be able to do without my help too much. Correlations is something that's really important. Again, you should have talked about it in 8th grade. It's an 8th grade standard along with a high school standard. It's kind of an overlap of something we do in both grades. Okay, if you haven't learned it before or for some reason you weren't paying attention when it was taught, that's okay. We're just relearning it today, and it's correlations. Correlations. So when we look at that word correlations, what's the prefix to the word? How does that word start? It actually starts with this co. It's a little goofy. It sounds like it's starting with core, but it's actually co. And we've talked about that word a lot, like with coefficient, cooperate. What does co mean again? What does co mean? Like co-worker, coefficient,
like teammate.
Teammate, together, two, good. So two things together, and what's our base word here? Relation. So we're really looking at how two things, what in the heck was that W? How two things relate to each other. Okay, and that's really what a correlation is it's relationship, relating, and it's two things, so two things together. Okay, we have three types of correlations. So kind of at the bottom part of your notes here, it's going to take up probably the rest of the space. We're going to break this up into three sections. We'll draw two lines. So 1, 2, and 3. So try and break it up evenly as best you can. Okay, so 3 spaces here for our correlations. We have 3 types. It's okay if it's not exactly split evenly. Okay, our first type of correlation, we're going to start on the left side here, is positive. A positive correlation. So as I look at a graph, most scatter plots are only in the first quadrant. So we're just going to draw the first quadrant there, X and the Y. If you think of a positive correlation, which direction might it be going? Yeah, going up, kind of. Yeah, up to the right. Okay, so if I have dots here in a scatter plot, dots don't always go on a line, kind of scattered everywhere. But generally speaking, we want it to be going up. So annoying. All right, and a positive scatter plot has a relationship of more. The more one thing happens, the more of another thing happens. Okay, the more of one thing, the more of the other. So maybe you're comparing the temperature outside. I'm going to say temp for temperature. What's something that would increase as the temperature outside increases? The temperature outside increases. What else is going to increase? Like how hot it feels? I mean, that's technically the definition of temperature, but yeah. What happens when it gets hotter? Probably like the more you sweat, right? The more water you drink, or the more people go swimming. Okay? So I'm going to say temperature outside and amount you sweat. Because that's for me, the hotter it is, the more I'm going to sweat. Okay, the colder it is outside, the less you're going to sweat. Generally speaking. Now, some people are crazy and they just don't sweat at all. So those people that would be called outliers. They don't follow the trend. But most people, the hotter it is outside, the more you are going to sweat. All right, so that's our positive correlation. It's a correlation where our dots are going up. Our data points look like they're kind of creating a positive slope. They're rising. So what would our next correlation maybe be? We have positive, we have negative. So in this case, what would it look like our points are doing? Yeah, going down. It's going to start up higher on the y-axis here and then work our way down. So again, there's not a straight line going down, but overall we can see the trend is going down. So this one's a little goofy because people are thinking it's less, but actually as we go along our x, as we go to the right on our x is getting bigger, but our points are getting smaller. So it's actually an opposite relationship. It's a more, less. The more something happens, the less of something else we have. Okay, so something that's really easy that you guys can relate to is your computer time. The more time you spend on your computer, what do you have less of? What? Yeah, less battery you have. I'm going to throw in that percent. Less batteries percent you have. Okay, now again, you might have a brand new computer. If you have a brand new computer, you get to spend a lot of computer time on it without the battery going down. You might have a really, really old computer where it goes faster. But most computers are going to be somewhere in that middle, where the more time you spend on your computer and the less battery percent you have. And probably in this experiment, we would assume that you're not plugging in your computer without it being plugged in. Okay, and then we have our last one. We have a positive relationship, a negative relationship, and then we have things with no relationship. So either when I compare two things, there should be a positive relationship, a negative relationship, or no relationship. So as we take a look at our no relationship, my points aren't going up, they aren't going down, they're going everywhere. They're all over. Okay, so for this one, we don't have a relationship. It's not a more, it's not a more, less. It's not a less, more. There's just no relationship between them. So for our example, would be like our number of pencils we own. So how many pencils you own and how much water you drink. Do you get to drink more water if you have more pencils? When you go to the water fountain to say, I need water, does it first ask, how many pencils do you have? And then gives you water based on that? No. If you have no pencils, does that mean you get lots of water? Nope. So if you have no pencils, does that mean you get no water? No, those two things have like nothing to do with each other. All right, we are going to create a scatter plot here to glue in. If you'd like to glue it in first, you can, or if you want to write on it first. Some of them don't have enough space to do like the x-axis label. But we are going to make a scatter plot. So go ahead, and if you want to glue this in on the next page, that's where I'm gluing mine in. And then after this, that is our notes. So if you want to try and work ahead a little bit, you can. First thing we're going to have to do is decide what we're counting by, and what our X and our Y is, what is our title. So as you take a look at the data I'm giving you, take a look and see what it's about, how we're going to create these numbers and these points. Did you? All the correlations? I feel like that's a little bit looking. Alright, so go ahead and glue this in on the next page, and then we are going to create a scatter plot. If you want to draw on it first before you glue it in, you can. You just might not have room for that for the x-axis on the bottom. All right, so as we take a look at this, what is our information showing us? What's one thing on our table?
Minutes practiced.
Good, minutes practiced and test grades. Generally speaking, what should happen as we practice more? What should happen with our test grade?
Higher grade.
Should go up. It should be a more. So is that a positive, negative, or no relationship? Should be positive. All right, so our thing that we do first when we do X and Y's, we think of kind of independent, dependent, or like a before and after. So is our X going to be the minutes practiced or the test grade? What do we do first? Yeah, first we practice, so that's going to be our X. And then we take a test. So that should be our Y. Most people do it in that order. Now some people do it in the opposite order, and it drives Miss Morrell insane. All right, so as I look at my X, my minutes practice, that's what I'm going to put on the bottom here. So here's my X-axis. If you want to draw kind of that line across to show that's the X, you can. Okay, so this is my practice. And how am I measuring my practice? I'm going to put it in parentheses behind. Our practice we're measuring in minutes. Okay, and we might need to count how many we have here. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. We have about 16 lines, not including the first one. So my lowest number, my minimum, is 5. And what is my highest number we have to get to? $152. So if I have 16 lines, what should I count by to get from 5 to 152? Yeah, just tens. Do I need to skip any? If I go 0 to 10, is that going to be space wasted? Nope, because we have a 5 and we have a 10. So we're going to start at 0, and then we're going to count by tens. So 0, 10, 20, 30. So go ahead and count by tens there. It helps to kind of write your numbers at an angle so that way they can look like they're close to that one number, you can. Or if you want to do that trick that we've been doing where we skip every other. Or if you just want to write small. Now, if you wrote minutes practiced on the bottom rather than practice and then parentheses minutes, or you might say practice time, minutes, either way, whatever gets the point across. Okay, and then on the y-axis here, that's the one going up and down. So this is our y. Our lowest percent we're starting at is, I think, 32. And our highest percent we're getting to is 100%. So what do I want to count by? First off, do I need to skip some, do I need to use a break? It starts at 32%. If I were going to go to 100%, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, I would probably count by tens. Do I need to skip from 0 to 30? If I go 10, 20, 30, is that over half my graph is wasted? Just 3 lines. You could use a break if you wanted to, but even if we used a break, we still would only count by tens. So skipping to that 30 isn't going to make a huge difference this time. So I still would count by 10. So 0, and then 10, 20. You could skip to that 30 and then count by tens, but again, that's not going to save us a lot of space. Usually we would want to do that if we were going to skip and then count by fives, or skip and then count by threes. But if I skip 3, I'm still going to have to count by tens either way. Okay, and then we do need a label for our y-axis, what those numbers represent. They gave us a really good label here, test grade, and it's in percents. So if you want to turn your notebook sideways, you can and write sideways, or you can just write it up and down, either way. And then we do need an overall title before we plot our points. Or we could plot our points and then do a title, but some of you I see are already starting to plot your points, so I want to make sure you get a title in. What should this, we don't really have a title overall, so maybe this was a specific test or a specific course, a specific class, or maybe you want to keep it generic. Genesis, what do you want this test to be about? What class? Math? Cool. Math tests. Amazing. Look at that. Math tests. All right, and then we're plotting those points. So for those points, when we look at our table, our points go up and down. So as I look at this, it's going to be 35, 74. Hi.
I have a story to tell you later.
Okay. Bye. All right, so we have 35 and 74. So as I find 35 on my X, I'm going to go 10, 20, 30, and then a little bit more for 35, and then up to 74. 10, 20, 30, 40, 50, 60, 70. 74 is not quite halfway, but close. Okay, we want to make enough of a point that it doesn't look like it's just a little dot or a little speck that just got there by mistake. So 35 should be exactly between 30 and 40. And then we're counting up to 70 and then a little bit more. Not quite halfway, if we can make it look a little less than half. Okay, 10 and 56. So write 10, right at 10 on that line. And then 56 would be between 50 and 60. A little more than halfway. Okay, I'll do one more together, and then I'm going to give you some time to finish it out on your own. 73, 87. So find 73, not halfway, so closer to 70. And then up to 87. So here's 80. 87 is closer to 90 than 80. It's more than halfway. So it should be a little closer to the 70 line and then a little closer to the 90 line. All right, we're on this third one here. If it helps for you to do like kind of some dots or X's as we go, so that way you know that you've plotted those ones where you're at. Okay, right now everyone should be doing the 42 to 65. But go ahead and plot the rest of these points. So you should have 1, 2, 3, 4, 5, 6. You should have 15 points on your graph. So keep plotting in the next points. Plot these points. Am I plotting 42, 65? Okay, you should be plotting the rest of those points. Okay, so we're plotting each of these points as we go. Okay, I have a couple questions. I know some of you, it sounded like put it away already. That's okay. You should be able to answer these questions without looking at your own. You can look at mine. All right. I have two questions about this graph. Okay, my first question is, why are there two dots with 68? So when I look at 68%, there's two dots there. Why?
Because they got the same grade twice.
Yeah, somebody got the same grade twice, but they studied for different amounts. So it's just two different students. Two different students got 68%. Good. All right, my next question, last one, is could this trend, if I extended this graph, I extended the x, keep going and going and going up to like 170, 180, 190, would this graph, would this positive keep going and going and going and going forever and ever and ever?
Yeah.
It would?
It wouldn't.
Can you get higher than 100%?
No.
No. Okay, can you study forever and ever and ever and ever?
No.
Sure. At some point, you got to take the test. You can't study forever. Okay, and then for some things, if you're studying, depending on what it is, the more and more you study, once you get to a certain point, you know everything, right? Would be the idea, where you know most everything, and you need to take the test. So this graph at some point is not going to go on forever and ever and ever. At some point, you have to stop studying. At some point, you're going to get 100%. Or at some point, you're going to just get brain rot, where you keep looking at your textbook over and over and over again, and you're like, your brain's not thinking. Do any of you guys do that when you study? You're just like, think, I'm thinking. You get to a certain point, and your brain's just like overstimulated. I don't know. My personal opinion. Okay, cool.